Predicting the future of a moving object requires payment in one of two mathematical currencies. You can use the strict, exhausting currency of vectors, tracking every individual force and shifting angle, or you can use the universal shortcut, the scalar currency of energy. Uniform circular motion is the most punishing scenario for anyone using the vector currency. Even if the car's speed stays fixed, its direction is changing every millisecond. In physics, that constant change in direction is a form of acceleration, forcing you to track a never-ending series of new angles. Calculating motion this way requires an infinite number of directional microadjustments. Using standard laws like F equals ma here is an accounting nightmare that demands a more strategic approach. We often talk about centripetal force, but it isn't a unique physical force. It is a job description for any force, like the tension in this string, that happens to point toward the center of a circle. This inward pull creates a common misconception. When we are inside a turning vehicle, we feel a centrifugal force throwing us outward, but that sensation is an illusion. This overhead schematic reveals the reality. A passenger's inertia carries them along a straight path, while the car's frame steers inward. The feeling of being thrown is just the body attempting to travel in a straight line while the vehicle moves beneath it. Constantly adjusting equations to account for these clashing directions and perceived forces is mathematically exhausting. To simplify the math, we need to switch to the energy shortcut. The mechanism that converts vectors into energy is called work. It is a strictly defined exchange rate that only cares about forces aligning with the direction of motion. The equation for work uses the cosine of the angle between the force and the displacement. This acts as a filter, effectively ignoring any force acting perpendicularly to the path of travel. When a force directly opposes motion, like friction, the angle becomes 180 degrees. This results in a negative cosine value, representing currency being drained from the system. Work functions as a mathematical launderer, taking complex, multidirectional vector inputs and outputting a single directionless scalar value. If we apply this exchange rate back to our circular motion problem, the entire nightmare disappears. Because the centripetal force always points toward the center, it stays at a perfect 90-degree angle to the object's forward motion at every single point on the circle. Since the cosine of 90 degrees is exactly 0, the inward force performs 0 work. The entire directional complication drops out of the equation. With the net work calculated, we can apply the work-energy theorem. This principle states that the net work is equivalent to the change in kinetic energy, 1/2 mv squared. By using this theorem, we can bypass the need to track time, acceleration, and shifting angles, trading the complexity of vectors for the simplicity of energy. Strategic physics depends on choosing the correct toolkit for the specific variable you need to find. If a problem provides a starting speed and asks for a final distance, especially on a complex curving track, it is most efficient to spend the energy currency. However, the energy shortcut is time-blind. If the problem specifically asks how long a trip took, you must go back to vectors. Similarly, if you are asked to calculate a strictly directional force, like the normal force of a ramp against a box, you have to revert to the strict accounting of Newton's laws. Physics is not about memorizing equations. It is a game of resource management. You use vectors for the granular directional details, and you spend energy to calculate the big picture.